So today I'm going to go through exercises regarding series summation and the tests we have to determine if the series converge or diverge. So first of all, we're going to look at this exercise, which we have sine of pi over 3 multiplied by n to the power of 3. So first of all, we know that this part is limited between 0 and 1. So we are going to increase this part to be 1, so the bigger part, and then we can write this. So we know that the summation is less than or equal to y divided by n squared. So first of all, we already know that this is converge, so we know that if we decrease it, it will also converge. But now we're going to show this by the integral test, which state that both the series and the integral established converge to converge or diverge together. So we are going to go through the integral here. So the integral of 1 divided by x squared is minus 1 divided by x, which converge to 1. So this series also converge because this converge and this is less than this is bigger than this. So if this converge, this also converge. So now the next exercise will be we are going to show if the series converge or diverge by the Cauchy condensation test. So Cauchy condensation test state that we can check if the series summation converge or diverge if we are going to take a new series, which will be only the natural log of the natural power of 2 multiplied by the same series we have before, but only on these places. So we're going to take the 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3, and so on, but only these places, and we're going to multiply them by 2 to the power of n. So then we are going to write it as this, and we know that these both theories are converge or diverge together. And do not worry, I will link all the information down below about a web page with all the tests and explain them and show even an example. So now we have 2 to the power of n divided by 2 to the power of n multiplied by the square root of n of 2 to the power of n. So this will be 1, okay, because we can write it the same as 1 divided by 2, the summation. So this will diverge, okay, because we can sum an infinite amount of halves. So I wrote it more formally that the limit of n when we take it to infinity of this will be 1. It's supposed to be half, and it's greater than 0, and then this indicates that this series also diverge. So now we're going to show the root test. So we have this series summation, and we want to show if this series diverge or converge. So we're using the root test, which states that if the nth root of the series is less than or equal to is less than 1, then the series summation converge. And if the nth root is bigger than 1, not equal, bigger than 1, then the series summation is diverge. If the series nth root is equal to 1, we cannot determine what happened and we have to use another test. So now we're going to take the nth root of this series, okay, and the thing we're going to have is that the nth root of an will be equal the nth root of n to the power of 22 and 20 to the power of n. So we know this will be approximately 1, so the limit of this is 1, and this have no limit because it's like the exact calculation, and we know this is less than 1, so this series converge. So now I'm going to explain like two aspects about this exercise, and we are going to use the ratio test. So the ratio test state that if there is in R such that R is less an plus 1 divided by an, when we take the absolute value will equal R and R will be less than 1, then the series converge. If R is bigger than 1, then this series diverge. So when we're going to take an plus 1, it will be n plus 1 multiplied by n squared, and this will be divided by n plus 1 to the power of n plus 1, and we're going to multiply by n to the power of n and divided by n factorial. So this will equal, the limit of this will be equal 1 divided by e, which is less than 1, then the series converge. Also, we can estimate this by another method, so we know that n factorial is approximately n to the power of n divided by e to the power of n. So if we are going to like approximate this, we can approximate that n factorial divided by n to the power of n is approximately like 1 divided by e to the power of n, which is less than 1 divided by n squared, which also converge. So this is another method. More, it depends on your teacher if the teacher allow you even to use this approximation. Generally, this approximation is pretty good, but it's dependent on the teacher if he let you or doesn't let you use this approximation. But generally, it's easier to use the ratio test if you have to check something similar to this approximation. So hope you like it. Please like this video, subscribe, please do it, and until next time, I'm out.